Today we're going to talk about order of operations for signed numbers. Before we can get into and actually start working through some of the order of operations problems, however, though, we do need to talk a little bit about our exponents. So when we are dealing with exponents, we want to be paying careful attention to what our base is. Remember, our base is our larger number in our exponential notation. That is a number that's being repeated over and over again. We can have positive bases if our number in there is positive, or we could have negative bases. So when we have a negative base, that means that we're going to have a negative number in parentheses. So if we look at this next example, we can see that in some of these we have positive bases, and some of them we have negative bases, and then in the last couple we have a negative sign out front of our exponential expression. So we're going to go through and talk about how we can deal with all three of these different types of problems. Right, so what we're going to focus on is our negative bases. So when we have a negative base, when we have a negative number in parentheses, right, our result is going to be positive if the exponent is even, and the result is going to be negative if the exponent is odd. Right? And when we're using this even and odd rule, it goes along with our multiplication and division. Right? But remember, this is only for our cases where we have a negative base. Right? We have a negative number in our parentheses. Okay. All right, so let's go through example 1 here and evaluate these different exponential expressions. All right, so 5 squared. 5 squared means 5 times 5. Right? We are multiplying 5 by itself twice. Right? 5 times 5 gives us just a nice simple 25. Right? If we look at B, notice that we have a negative number in parentheses. So since we have a negative number in parentheses, we have a negative base. So when we write our negative 5 squared, right, we could write that as negative 5 times negative 5. Well, according to our rules from the last section, right, negative times negative turns positive. Right, so negative 5 times negative 5 gives us a positive 25. This matches our statement above. Right, our result is positive if our exponent is even. Right, so we have a negative base, we have a negative number in parentheses, we have an even exponent, and our result is positive. Right. C, we do not have a negative base. We just have a negative sign out front of our expression. So what this means is there's one negative sign in front of our 5. So this is the same as negative 5 times 5. We don't repeat the negative sign because it is not in our parentheses. Right? One negative sign means our result is negative. Right? So negative 5 times positive 5 gives us negative 25. So the parentheses do make a difference. We have parentheses in B. We have a negative base. We have a negative base. Right? Our negative sign is repeated and we get a positive product. Here we do not have parentheses and we get a negative answer. Right? So for D, now we're going to, for D, E, and F, we're going to look at some different cubes. 3 cubed means 3 times 3 times 3. Well, 3 times 3 is 9. 9 times 3 gives us 27. So 3 cubed is 27. Right, negative 3 cubed. Well, now we have a negative base because we have a negative number in parentheses. Right? Negative 3 times negative 3 times negative 3. Right? 3 times 3 times 3 is still going to give us 27. But remember, if we have an odd number of negative signs, we get a negative result. Right? So our base is negative and our result is negative because our exponent is odd in example E. Right, F, just like this one over here, we only have one negative sign out front. So negative 3 times 3 times 3 gives us negative 27. Right, so in this case, our answers to E and F are the same. They're both negative. Over here, we had different signs based on our negative bases. So as you're going through and you're working through exponential expressions with negative numbers as bases, or positive numbers or negative signs out front, we just want to make sure that we are evaluating these correctly. When in doubt, you can always feel free to write out the repeated multiplication as I have in this example to make sure that you get the correct sign in your answer.